Alright, so hello everyone, welcome to the session. Let's see then what we have interesting in today's session. Today we will be discussing about this topic, polynomials, right? Okay, and before starting the topic, let me introduce myself. So my name is Seema and I am your maths tutor. Okay, so look at this about the topic polynomial. Let us recall few basics that you already know in your earlier grades. You have already read about few things. Let me recall those things. Okay, so if you remember the word algebraic expression, any idea what do you mean by algebraic expression? Let me take an example. Let's suppose 2x plus 3. Now, can you tell me whether this given expression is an algebraic expression or not? So, if you remember, any expression consisting of constant variable, so that is an algebraic expression. Okay. Now, then what do you mean by polynomial? Polynomial is also an algebraic expression, but there should be conditions. Okay. Few conditions to be fulfilled, then only we can say it should be a polynomial. Okay, now let's discuss about polynomial in detail. And one more thing, let me discuss over here that polynomial itself consists of two words. If you see that poly means many, okay, and nomial means terms, means any expression consists of multiple terms, or we can say many terms, right? Many terms. Okay, now as I told you, there will be few conditions to be a polynomial, so we will be discussing that also. Now let's take an example. Let's suppose 5x square plus 2y minus 7. I have taken this as a algebraic expression. I will discuss why we are telling this as a polynomial. First of all, look at few things like 7 is a constant over here, x and y, these are the variable, and any number attached with this variable, you can see over here, these are nothing but exponent. 5, 2, an exponent, any value raised to the variable, so those are nothing but exponent. Okay. Now, what are the conditions to be a polynomial? Let me write down over here. Everyone noted down this thing. Okay. Conditions to be a polynomial. Okay. So, first condition that is very important about the exponent, if you observe over here in the first term, 2 is written exponent over here, 2. And over here, if no value is present, we can consider it as 1. By default, we are considering it as 1. Okay, sorry. Just a minute, let me show you the slide. That is 1. Okay. I hope no issue over here. So just remember the exponent, it should be a whole number. Okay, it should be a whole number. What is whole number if I'm asking you 0, 1, 2, 3? So exponent, it can be any whole number. So this is the first condition. Let me write it over here. Exponent, it should be a whole number. Okay, I hope no issue in this regarding this. It should be a whole. Now, what about the second condition? Second condition is that about the coefficient. You can see 5 over here, 2, these are the coefficient. So, for coefficient, it can be any real number. We can take anything. And you know what are the real numbers? We can take any natural number, whole number, integers, anything. Rational numbers all come under real number. Right? You have already read in the first chapter real number about that. So, coefficient, it should be a real number. Let me write down over here. Coefficient, it should be a real number. Okay, I hope no issue regarding this. And if you have any doubt, just comment below in the comment section. Okay, or you can raise your hand and you can ask whatever doubt you have. Okay, so now let's talk about the variable. Okay, now what are the conditions for variable? So for variable, there is no limit for variable. Okay, let me write down over here. No limit for variable. You can take n number of variable, x, y, z, anything. Okay, just a minute. What is happening? Let me go to the slide. Yeah. Okay. So these are the conditions to be a polynomial. So look at this. A polynomial is an algebraic expression consists of variable, coefficient, and constant combined using addition and subtraction operation. Okay. As you can see, three condition. Exponent, it should be a whole number. 2, 1. Over here, you can see no coefficient is present over here. We can consider it as 1. By default, we are considering it should be a whole number. Coefficient, it should be a real number. And variable, not it. Understood? So this is one of the example you can consider for polynomial. This is also one of the example written over here. Okay. I hope no issue regarding this. Alright. Now, so why I'm discussing about these conditions? Because after the session, when you solve the question, from your book exercise. So you will see a few questions are there that whether the given expression, algebraic expression, is a polynomial or not. How you will check? By using the condition. Okay, understood? Now let's come to the next topic about terms and degree. Okay, if you remember in the when I'm discussing about expression, we are discussing about these are the terms. So what are the terms then? Okay, so look at this. Note it down. Okay, any doubt? Just ask as I told you. Okay, terms. Each part of a polynomial is separated by a plus and minus sign. Over here, let's take an example. This one. 2x cube plus 3x square minus 5x plus 7. So in this given polynomial, we have how many terms if I'm asking you? So you can check 1, 2, 3, 4. So we have 4 terms. Okay. No issue regarding this. I hope it is clear. Just a minute. What is happening? Let me check. Yeah, it having 4 terms. Each part of the polynomial separated by a plus minus sign. 4 terms are there. Okay. Understood about terms we have discussed. Now what is degree then? Degree means highest power of the variable. Highest power of the variable of the any polynomial. You can see in the previous expression we have 2 and 1. They are the expression. What will be the highest 2? So we can say for the given polynomial, for this particular polynomial, what will be the degree? It is 2. Understood? In the same way, if you observe in this expression, we have 3 also there, 2 is there, 1 is there, then what will be the highest? So 3. So 3 will be the degree for that polynomial. Understood? I hope no issue in this. So we have discussed about polynomial, we have seen few examples, conditions we have checked, terms, degree we have discussed. Now let's come to the next topic, that is types of polynomial. So if you remember, we have discussed about in various polynomials, we know having multiple terms, many terms, right? So if we have only one term, then two terms, we have various names given for such polynomial. Okay, look at this. If any polynomial consists of one term, like these are the things, you can take an example. So those are known as monomial. Okay, so those are monomial. Now if any polynomial like any expression consists of two terms, you can see this example consists of two terms, so they are binomial. Don't know what is happening. Just a minute, let me check. Yeah, it's fine now. Okay, now if it having three terms, then that is a trinomial. Okay, as we already know, having many terms, so those are nothing but it's a polynomial. Understood? Types of polynomial based on number of terms. Now let's come to the next thing, that is types of polynomial based on degree. Okay, if you remember what is degree, if I have already discussed. Everyone comment below in the comment section. Tell me what is degree. Anyone? Any idea? Yes? Very nice. Highest power, or you can say highest exponent of the given expression. Okay. So over here, if you observe 2x plus 3, if I'm asking what will be the highest, so you will say 1. So 1 will be the degree. So that is known as linear polynomial. Okay. Now if it having two like exponent, highest power, highest exponent, so that is known as quadratic. And if having 3 degree, that is cubic, and with having 4 degree, that is quadratic. Don't confuse with quadratic and quadratic, everyone. Okay, understood? All right. Now we have a few things. You can see it is written over here. Degree 1 form a straight line. What is that? Okay. Now look at this. You have already read in your lower grades about how to plot the points in the graph paper. Okay. In the same way, when you're plotting this expression in the graph paper, for linear polynomial, you will be getting a straight line. We will discuss in further in the session or in the next session. Don't worry about this, how it forms a straight line and all, right? Just remember few things. For quadratic polynomial, it will form a parabola. For cubic, it forms a complex curve, and quadratic, it will even form a complex curve, right? So understood everyone about types of polynomial we have discussed based on terms, based on degree. Okay. Now let's come to the next topic, that is zeros of a polynomial. So what do you mean by zeros then? Okay. So let me discuss few expression that we have already discussed at the starting. If you remember, 2x plus 3. If I am asking you what will be the value of the that expression, value of the expression, value of the variable, what will be the value? So that is nothing but it is known as zeros. Okay, like suppose we have example over here, that is x square minus 4. So what will be the value of x? How you will find out? You can see zeros of a polynomial px is any value of x that makes px equal to 0. It means that when you are putting any value in the given expression, in the value of x, so that the entire expression will become 0. So that will be known as zeros. And how you will find out? How to find out? You can see, just equate this expression to 0. Okay, so when you're equating, you can see we are getting x equal to plus minus 2. So we have two values. It means by putting those values in that expression, you will be getting the polynomial will become 0. Okay, let's look at this. Let's suppose I am putting x equal to 2 over here. What you will get? Okay, so when you are putting 2 square minus 4, you can see 4 minus 4, it will become 0. Understood? It means that 2 is one of the value, 2 is one of the 0. In the same way, x equal to minus 2 is also one of the 0 for this polynomial. Okay. So we have discussed about various things. Now, let's move on to the next topic. So we have discussed about zeros. Now let's go to the next topic, that is remainder theorem. Now what is remainder theorem? From the word itself, you know, you have heard about this word remainder, where when you're dividing something, at the end whatever you are getting, that is nothing but it's a remainder. Okay, so same thing over here. Let's take, we have any polynomial and it is divided by any expression. Okay, just a minute. Okay, all right, so I think it was erased. Yeah. Okay, so look at this. Any polynomial is divided by x minus of a. Okay, so it means that we have to divide and then only you will be getting the remainder. But I will say in remainder theorem there is no need of odd log division, no need of exact division. Instead of that, what you will do? Let's check it out. So let's take an example. You can see I have taken one example. Px is one of the polynomial and we have to divide by x minus 1. So what you will do in that case? So just from this you have to find out the value of x. Okay, so x minus 1, how you will get the value? If you remember in the last slide I have discussed, that is just by putting equal to 0, x we are getting equal to 1. Okay, now what you will do? Just substitute the value of 1 over here in this given polynomial. Okay, so look at the next step. When you're putting, we are getting 6. So 6 is nothing but it's a remainder for the given polynomial. Understood? Okay. Okay, I hope no issue regarding this. Note it down everything. So instead of long division, what you will do? Just you have to substitute the value from this and you will be getting the remainder. Okay, so this is one of the theorem that you need to remember. Without actual long division, you will find out the remainder. Next we have the factor theorem. Okay, now look at this word factor written over here. We have already read about, I mean to say, heard about this word, right? After that we will be discussing about identity. Factor. So you have already heard about. Let me take few simple basic example, like suppose 6. So if I'm asking you, tell me what are the factors of 6. So what you will say? Tell me. Means what are the numbers which exactly divide it, which you can say completely divide 6. Here you will say 2, 3, 6. So these are the numbers which exactly divide 6. Means at the end by dividing you are getting remainder as 0. Understood? About factor. Now what is factor theorem then over here? If you remember, we have read about that how sorry, a polynomial is divided by like another polynomial, another expression we can say. How you will find out the remainder? By simply remainder theorem, by putting the value. Remainder can be any number you will be getting, or it can be 0 also. Okay. In the same way over here, whenever we are getting the remainder as 0, so it means that that given number is a factor, you will say. Okay, let's take an example. Let px is equal to x square minus 5x plus 6. Okay, by substituting the value of 2 over here, we are getting the remainder as 0. It means that x minus 2, you can say it is one of the factor for this given expression. Okay, so factor theorem, it says that whenever when you're putting any value in that expression, you're getting p of a is equal to 0. So remember, whenever you're getting a 0, then x minus of a is nothing but it is known as a factor of that polynomial. Okay, I hope no issue regarding that. This what is factor theorem. Okay, now let's come to the next topic, that is essential polynomial identities. Okay, what are the identities? So why we are telling, I got few questions, some of the student like ask about this. Let me discuss those things. Why this given you can say equations are known as identity? Because it is a general formula, we can say it is true for any value. Okay, so what are identities? Like x plus y whole square, it is equal to x square plus 2xy plus y square. So whenever we are putting any value, you will see the left hand side it will be equal to right hand side. So whenever why we are telling the given equations as identity, because it is true for all the values. Just remember this thing. Okay. So now the next thing, negative perfect square. So x minus y whole square, it will be equal to x square minus 2xy plus y square. Now the general expression, we have the next thing, that x plus a into x plus b, it is equal to x square plus a plus b into x plus a. Now three variable identity, it means we have three terms. On that case, it will be, let me write it down over here. If it is not visible, then x plus y plus z whole square, it will be equal to x square plus y square plus z square plus 2xy plus 2yz, okay, plus 2zx. So this is the general identity, you can say. So you have to remember this identity, because these are the building block of the advanced algebraic manipulation. Okay, now we have read about various things about polynomial, right? We have discussed the conditions to be a polynomial, what are different types based on terms, degree. Now what is the use of polynomial? Because whenever you read any topic, you must be thinking that what are the real world application where you can apply this, right? So you can see physics and engineering, you can apply over here. Motion equation, use polynomial to describe velocity, acceleration and trajectory path in projectile motion and wave analysis. So this is one application. Another, we have economics and business, there we will also using polynomial. Constant function in computing also, there also we can apply. Okay, so for data analysis, algorithm design using use polynomial for curve fitting and mathematical modeling. It means that polynomial forms the foundation for advanced mathematics. So you have to master them to excel in higher studies. Okay, yeah, that's it for today's session. I hope you have understood whatever we had discussed today. Okay, I hope you like the session. That's it for today's session. I'm ending the session. So bye everyone.